Hello, good morning and good afternoon, depending on where you're joining us from today. My name is Fabio Eiring and I'm a student at the University of Bayreuth, and together with Dominik Schönborn and Dr. Christoph Buck, we worked on the topic of the digital transformation of the value chain in tomorrow's automotive industry. The goal of our research was to derive theoretical and practical implications on how software can tackle present and future challenges. On this slide, we summarize the most important foundations for our research. As a result of the digitalization, companies, as well as processes and products, become increasingly digitized. The biggest challenges posed by the digitalization are a higher complexity, short technological life cycles, and stricter regulations. The main challenges regarding the automotive industry are environmental awareness, urbanization, and demographic change. This leads to the three main technological trends: electromobility, autonomous driving, and connected cars, which will drastically change the understanding of mobility. On this slide, you can see a graphic of an extensive study by Roland Berger and the RWTH Aachen University on behalf of the German Ministry of Economics. Here, the future trends and challenges of the automotive industry as well as their interrelationships are clearly presented in the context of an industry outlook for 2030 and 2050. Based on four central megatrends, various challenges are defined which lead to two technology paths in the vehicle. The relevant fields of action are defined at the end of the graphic. The focus of our work is on the right-hand side. We've worked on the relevant topics in green on this slide. Now onto the conceptual background. The value creation of the vehicles consists of 5 stages, being design, development regarding the software as well as the hardware, production, sales, and service. While established OEMs are covering all these stages most of the time, new players are focusing only on specific stages, for example, software development. The reason for this is the know-how gap of established automotive manufacturers in the area of software and services. The technological trends also shift the focus and thereby affect the strengths of established players, forcing them to adjust their activities. Through this shift, more and more established tech companies and startups are entering the market with adjusted business models. The vehicle of tomorrow is summarized as MADE, which describes key trends and technologies. Firstly, mobility as a service. Vehicles of the future will be used in the context of the sharing economy. The relationship of the user to the vehicle is shifting from vehicle ownership to vehicle use based on services. On the technological side, vehicles of tomorrow will be able to drive autonomously, meaning that some to all driving functions will be automated. Vehicles will be fully digitized and deeply connected with the environment, the internet, and other vehicles. And of course, the vehicle of tomorrow will also be electrified. Now on to the methodology. We performed a multivocal literature review after Garussi et al., including white academic literature as well as gray practical literature. Our scientific literature review was based on the Web of Science. First, we defined a search string and filtered our results. This search resulted in 334 articles, which we then evaluated after several criteria. That led to us having 38 articles included. Our gray literature review was based on Google. We included studies, reports, press releases, statistics, and also specialized magazines. We again applied our search string and evaluated our results based on the 6 shown criteria. This led to us also including 38 results of the gray literature. For the analysis of the literature, we assigned our 76 results to this matrix. For the analysis of the literature, we assigned our 76 results to this matrix following a framework of Risius and Sporer. This matrix consists of several levels of analysis as well as activities. The first column contains results that describe basic technologies and approaches in the context of digitization. In the second column, the value proposition, we describe sources including the benefits and value generated by software solutions and digital technologies, as well as their applications for the players of the value chain. In the third column, management and organization, we describe sources relating to the management and organizational aspects of software in the vehicle, the industry, and the society. The focus here is on digitization and the interaction between the stakeholders. Fourteen of our results could be assigned to this column. In the first level of analysis, we were able to assign 7 results. We found a focus on cybersecurity with different approaches being taken, for example, a blockchain-based approach. Also, the central aspects of over-the-air updates are evaluated. The second level of analysis involves technologies and their impact at the enterprise level. Here we were able to identify gaps in the field of scientific literature with 1 result. On the part of the gray literature, there's a concrete Industry 4.0 software solution, Catena X, for the interaction of industry players with each other. However, apart from that, it can be seen that hardly any concrete software solutions are mentioned here. In the third level of analysis, we also identified gaps. In addition to a blockchain-based network architecture for smart cities on the scientific side, we were only able to assign 2 extensive consumer studies on the gray literature side. The second column contains 23 sources that treat the value proposition benefits and generated value by software solutions and digital applications. The results relate to different trends and fundamental technologies, as well as their applications for the players, the value chain, and the vehicle itself. In the first level, we were able to assign analysis and research on the aspects of the 2 central trends or technologies, autonomous driving and connected cars, as well as the associated potentials and threats. The scientific literature pursues many theoretical approaches here. The gray literature, on the other hand, mainly refers to over-the-air updates and their monetary potentials. Results related to the value and benefits of software for business and industry have been assigned to the second level. The scientific article showed that even small suppliers can have a major impact on a company's product development and innovation power. On the part of the gray literature, the impact of technological trends in the vehicle on the business models of companies was evaluated and necessary adjustments were derived. We were able to assign 4 very specific articles to the third level, for example, on the impact of autonomous driving on tolls or the time savings of autonomous driving. The gray literature revealed 3 studies on consumer preferences, including privacy and other concerns of connected vehicles. The last column of the matrix includes sources related to the management and organizational aspects of the in-vehicle software, the industry, and the society, and contains, with 43 of our 78 results, by far the most on the activity scale. We were able to assign a total of 9 results to the first level regarding concept and architecture. On the scientific side, the aspects of technological solutions for digitization, connectivity, and software engineering were discussed here, as well as data-driven decision-making. The gray literature shows the importance of vertical integration in the company and the interaction between corporate IT and product IT. One study also deals with the technological aspects of electromobility. The majority of the results are found in the second level of analysis of this activity, which can be attributed to the numerous economic aspects as well as the dynamics within the industry and the companies, both on the part of the scientific as well as on the part of the gray literature. The most results could be assigned here. In summary, the effects and potentials of digital technologies on companies are discussed here on the scientific side. The gray literature focus on the relationship between industry players and the necessary adjustments with regard to the defined trends and challenges of the automotive industry. Especially the topic of cooperations is of central importance here. Finally, 6 results could be assigned to the level of analysis users in society. The scientific literature examined the impact of smart mobility on a society level. The gray literature consisted of various studies. Both the consumer studies already mentioned could be assigned here, as well as a study on the infrastructure for e-mobility in various markets and a study on the effects on the labor market and society. After our analysis, we were able to derive implications. Companies should retain core competencies such as body quality and ride comfort, since the future cars will be defined by software and there will be less differences created by the hardware. Apart from that, companies should create holistic, in-house developed and brand-specific digital platforms and ecosystems in the long term. To bridge the gap in software competencies, cooperations and acquisitions should also be considered. The brand's image should also be leveraged for future mobility services. Therefore, trends and consumer preferences should be closely monitored and the services should be adjusted regionally. Also, within industry and between companies, digitization will be essential. Shared databases for information exchange should be used. We were also able to derive some theoretical implications for future research. During the analysis of our results, it's obvious that the main findings in scientific literature were assigned to the management and organization, as well as the value proposition. Apart from that, there were some theoretical and statistical models with little to no benefit for practice. There also is a lack of concrete, practical software solution models and services which should be researched in the paper. Research should continue on solutions and concepts in the area of cybersecurity, as this is a mandatory and crucial requirement for digitized technologies in vehicle and also driver safety, and therefore should have high priority. Thank you for your attention and for listening to our presentation. Dr. Christoph Buck will be happy to answer your questions during the colloquium.